Everyone. Today, as part of our ISC activity of fuzzy systems, our group consisting of myself, Bashamitra, Sumit and Vaishnavi are going to present an on topic medical diagnosis of diabetes using fuzzy cells. One of the applications of fuzzy system is in medical field. As medical symptoms are often uncertain and vague, traditional diagnosis of symptoms are often relies on numerical threshold. For example, if a person has diabetes range blood sugar level of 140, then he will be considered as diabetic. However, this method can lead to misclassification because if sometimes a person with a sugar level of 140 might not be diabetic, and sometimes a person with a normal sugar level can be diabetic. So fuzzy logic provides flexible decision making using degrees of membership. A fuzzy set is a concept in mathematics and logics that deals with vagueness and uncertainty. Unlike traditional sets that have elements either fully included or fully excluded, fuzzy sets allows elements to be in the membership degree of 0 and 1. For example, in a traditional diagnosis system, a person with blood sugar level of 140 might be considered as strictly diabetic or non-diabetic. However, diabetes is a gradual concept and different people show symptoms at different sugar levels. Fuzzy sets allows to say that a person with sugar level of 150 might be partially diabetic rather than giving a strictly yes or no. So there are certain parameters that allows to analyze diagnose diabetes, which are blood sugar level, which is the presence of glucose in the sugar in the blood, and body mass index, which is the ratio of height and body mass. Other symptoms include frequent urination, fatigue, blood vision. Each of these parameters is assigned a fuzzy membership function.
Now we will discuss about how we calculate the diabetes using the membership function. For that, first we will discuss about blood sugar level membership function. So here is the range is represented for the different levels of blood sugar, different ranges of blood sugar. So first is the low, then normal, and third is the high. If your blood sugar level is between 0 to 80, then the person has a low sugar level, and if the person has blood sugar range from 80 to 100, then that person is normal, means it fit and fine, and if the person belonging from 120, belonging their sugar level from 120 to 150, then that person has a high blood sugar level. See, here is the membership function for representing for low blood sugar level. So if here X represent the blood sugar level is is less than 80 or equal to 80, then it has low blood sugar, and if the X belongs to the 80, is between 80 and 100, then it has partially low sugar, and if X is greater than 100, then it has not a low sugar, means this person is not a diabetic. Next one is the BMI membership function. BMI means body mass index. So here is the categories for describing various ranges of body mass index. So here is underweight. For underweight, there is a range from 0 to 18.5. Next one is the normal. It has a 18.5 to 24.9, and this is the overweight. It has index belonging from 25 to 29.9. And see, here is the membership function for the overweight. X is representing the body mass index. If body mass index is less than or equal to 24, then it is not considered in the overweight. And if X belonging from 24 to 29, means it is partially overweight. And if the
Now I will tell you about the diffusification process in which we will convert the result of fuzzy logic to a crisp result, that is whether a person is diabetic or not. We all know that the fuzzy logic will give the result in the range value, so we need to convert into a finite single value that can be understood by a person and a doctor. We use three methods for it. First one is centroid method, in which the result of the fuzzy logic will be converted as a weighted average of all possible outcomes. Second one is mean of maximum, in which the result is the average of the highest membership function. And third one is max membership. In this max membership method, the category with highest probability is chosen as a result. Like if using fuzzy logic, a person is having diabetes 75%, it means the risk of if the result is 75%, it means the risk of person having diabetes is very high. Next is binary conversion from fuzzy to 0 by 1. So we need to give the result of diabetes. We need to give the result of the person in the form of whether the person is diabetic or not, that is yes or no, or we can say in binary 0 or 1. So we use a threshold method for it. The threshold method is that if the risk factor is greater than 0.5, we classify it as a 1, that means the person is diabetic. And if the risk factor is not greater than 0.5, that is less than 0.10, we will mark it as 0, that is person is not diabetic. Second method for it is the range based classification. For example, range from on the scale of 0 to 1, we will mark the range from 0 to 0.4 as a low risk, and from 0.4 to 0.7 as a moderate risk, and from 0.7 to 1 it is a high risk, that is a person is highly diabetic. So why we need the fuzzy logic for it? We need a fuzzy logic because it handles the uncertainty in medical field, and second one is that it provides a more flexible approach than the traditional threshold method. Third one is that it can improve the efficiency of clinical decision support system. And this fuzzy logic method is not only useful for diabetes, but also for we can use it for diagnostic other problems like mental problem or heart disease, kidney problems, etc.